Hi, this is Mrs. May. Today we're going to look at solving equations and inequalities and solving for the variable within those equations. We're going to start out with a simple equation of x plus 7 equals 4. And in that equation we have an addition of 7, and to isolate the variable we need to do the opposite operation of adding 7, and we are going to subtract 7 from both sides of the equation. When we do that, we end up with x by itself, because a positive 7 minus 7 is equal to 0. 4 minus 7 is negative 3. For those of you who guessed ahead that the answer was negative 3, this was just a simple way of doing the equation by isolating the variable. Once you have your answer, you always want to put it back into the original problem to double check your solution. So we have a solution of negative 3. We're going to put that back into the equation. We have negative 3 substituting for x plus 7 is equal to 4. Is that a true statement? Negative 3 plus 7 is equal to 4, and the solution checks out. For our next equation, we have negative 6 times x is equal to 48. Again, we're going to be looking at isolating x, getting it by itself. This is a multiplication problem, so we want to do the opposite operation of multiplication, which is division. Remember that the fraction symbol is also the division symbol. So when you are multiplying by negative 6, you can divide by negative 6 on both sides. A negative 6 divided by negative 6 is 1, and 1 times x leaves x by itself. And 48 divided by negative 6 is negative 8. And when you put that back into your original problem to check your solution, is negative 6 times negative 8 equal to 48? And yes, it is, so that solution checks out. Our next problem, we have 1/4 times x equal to 5. Or another way to think of it, instead of 1/4, is 1 divided by 4 times x is equal to 5. 1 divided by 4 being a division problem itself, the opposite operation of that is to actually multiply by 4. Or you can think of it as we're multiplying by 1/4, and you could do the opposite of that, is to multiply by its reciprocal, which is 4 over 1. So however you want to think about it, whatever is easiest for you. Again, this being a division problem, to me it's just simpler to multiply by 4 on both sides. When we do that, 1/4 times 4 is equal to 1. 1 times x is x, and that leaves us 5 times 4, which is 20. And again, you can substitute that back into your original equation. Is 1/4 times 20 equal to 5? And yes, it is, and that solution also checks. And then for our last problem on this page, we've got x divided by 4 is equal to 5. Again, this is a dividing by 4. You can simply multiply by 4 on both sides of your equation. This will leave you x by itself. X is equal to 20. When you put that 20 back into your original problem, you get 20 divided by 4 is equal to 5, and yes, that's a true statement, and that checks out. So 3 single step solutions for equations. The next one we're going to look at is 3 different types of equations that I want you to solve by yourself. So take a moment to pause the video and write these into your notes and solve these, and in a minute I am going to solve these with you. So please pause the video. Alright, very good. We should be hopefully solving these correctly. We're going to take a look at the first one. X minus 5 is equal to 3. We've got a subtraction problem, subtracting 5. The opposite operation for that is to add 5. I'm going to add 5 to both sides of the equation, again being fair to both sides of an equation. we get x is equal to 3 plus 5, which is 8. And then putting that back into our original problem, we get 8 minus 5 is equal to 3. That is a true statement, and that problem checks out. The second problem, we've got negative 65 is equal to negative 5 times y. The opposite operation of multiplying is to divide, so we're going to divide by negative 5 on both sides of the equation. Negative 65 divided by negative 5 is a positive 13 equal to y. And putting that back into the original equation is negative 65 equal to negative 5 times 13. And yes, it is, so that problem checks out as well. And the last one on this page, we've got t divided by negative 3 is equal to 9. This is a division problem, so we're going to do the opposite operation. We're going to multiply by negative 3 on both sides. This leaves you t equal to 9 times negative 3, which is negative 27. Putting negative 27 back into your original problem is negative 27 divided by negative 3 equal to 9. Yes, it is, and that checks out. So hopefully you got all three problems right and are ready to move on to some inequalities. We've got an inequality here of 5 plus y is greater than 8. The difference between an equation and an inequality is simply the sign right here, that greater than sign. Instead of it saying equal to, it says greater than. So that's the main difference between an inequality sign and an equal sign. So we're going to be taking a look at just solving inequalities, but in the same form that you would solve an equation. So we've got 5 plus y is greater than 8. This is an addition problem, so you do the opposite operation to isolate y. You would subtract 5 on both sides. And this leaves you with a solution of y is greater than 8 minus 5, which is 3. And again, you can substitute in your solution, but it's going to look a little bit different when you do that, because when you put in the 3 for y, we would say 5 plus 3 is greater than 8, but that is not a true statement. If you look back to your original solution, it says y is greater than 3. So you could simply, instead of saying, putting in the 3, the next larger number than 3 would be 4. So if you said, okay, 5 plus 4 is greater than 8, is 9 greater than 8? Yes, that's a true statement. So there is a little bit of a way to double check it, but you would not want to put in just your solution, because this is a set of numbers. This is saying there's a set of numbers greater than 3 that makes this a true inequality. Other types of problems you will see is a solution is given to you and you have to determine, is it a true solution or not a solution at all. So we've got an equation here, n times 21 minus n is less than 100. Is 8 a solution to the problem? Is 8 part of that solution set? So in order to figure that out, you would need to substitute in the 8 where the n is located. So we're going to put in 8 times 21 minus 8 is less than 100. And going back to our order of operations, we know that we have to do what is inside the parentheses first before we do this multiplication. So we've got 8 times 21 minus 8, which is 13, is less than 100. And 8 times 13 is 104. Is 104 less than 100? No, it is not, so this is not a solution. 8 is not a solution to the inequality n times 21 minus n is less than 100. So that would not be a solution. Next I want you to pause the video and just see if you can find the inequality solution for x in this equation. We've got 20 times x plus 100 is greater than 260. use the order of operations to solve this. This is a two-step equation because we've got this addition of 100 on this. So pause your video, see if you can solve this. Okay, so the first step we have is an addition problem of 100. We are going to minus 100 on both sides of this equation. And that is going to leave us 20 times x is greater than 160. And because this is a multiplication problem, 20 times x, we are going to divide both sides by 20. Remember that fraction bar means to divide. And we've got x left alone is greater than 160 divided by 20, which is 8. So x is greater than 8. So in order to double check this, the most simple way is to go one number above your solution. So you've got x is greater than 8, so we're going to choose 9 to double check this and substitute in 9 where the x is located and see if it makes a true statement. We've got 20 times 9 is 180 plus 100 is greater than 260, and 280 is greater than 260, so that is a true statement. The last thing I want you to do is take a look at this real world problem and pause the video, read it, see if you can come up with an equation and solve to find his average speed to the nearest tenth of a meter. So go ahead and pause your video. So meters per second, just so you know, meters per second can be written meters divided by seconds. So we got meters per second. And again, that fraction bar means divided by, but it also means that word per. Think of miles per hour. We're talking about meters per second. Substituting the known values into the equation, if we go back to our original problem, we have 200 meter dash and 19 and 79 hundredths seconds. So we've got a 200 meter dash divided by 19 and 179 hundredths seconds. This is your meters, this is your seconds. That would be just one way that you could go about solving that. So when we do this calculation, we come up with an answer of 10. I'm going to put this in thousands. It goes much further than that, but we've got 10 and 106 thousandths. And in the original problem, it says to round to the nearest tenth of a meter per second. So when you do the rounding, sorry about that, when we do the rounding, it rounds to approximately 10 and 1/10 meters per second. Hopefully you were able to get that one correct as well. So this has been your lesson on solving one-step equations for equations and inequalities. Thank you for watching.